Hello there. Sorry about the delayed. Yeah, there are some technical difficulties, and sorry you have to look at me at a weird angle, but I think it's a fun angle to look at me. But anyway, so hello, I'm Cheuk, and I'm going to give this talk about hypothesis. So like all my presentation, I always said that the first slide is the most important slide because you got the link to get this slide, right? So you don't have to ask like, oh, where can I get the slides or things like that, but you got the link here already, so which is great. And also there are my contact details. I'm still on Twitter, but if you prefer Mastodon, same handle, you'll find me as well. Let's move on from there. So I start the talk by asking a question, so you can answer it yourself silently. I don't have to know it, but if you want to share, feel free to share in the chat. So what's the most difficult part of writing the test? For me, this is my answer for myself. So for me, it's like importing the code, because sometimes when you have a big kind of project, then you have a lot of multiple files, and sometimes like you don't import the code correctly, and then PyTest can't find your code, which then it doesn't work. Then another thing is to organize the test. So again, if you have a huge project, right, like you have a lot of tests that you have to test it out, and so yeah, like if it can get messy very quickly, that you have a lot of tests, you don't know where to put them, and then they just like scattered everywhere, and you just after a while you just forget where they are, and just a big mess. The last thing is to think of some test case, because a lot of times when we do tests, we have to think of what example we should use to test, and how many example we should get for each test, to kind of deal with all the situation, because when your code go into production, anything can happen. So sometimes I ask myself, is my test good enough? Have I encountered all the situation? So so these are quite like challenging things when we think about testing and think about writing the test. For me, I think that hypothesis can help me. Well, it can't help me for importing my messy code anyway, but it will help me with organizing the tests, because instead of multiple tests that you have to write, you only need to write one test. And the next thing is that it will kind of help you to choose the edge cases to test your code properly. So before I jump into it and tell you how I get help from Hypothesis, or how Hypothesis can help you, I'm Cheuk. I am working for Anaconda. I was involved in a lot of open source project in the past. I love open source, so that's why I love open source project. I love talking about them. And I organized a lot of events and conferences in the past, and I just love to go to all of them. So if you see me in the future in any events, please come and say hi to me. I won't bite you. I'm like, just say I will talk to you, and like if you have any questions or any idea about how to use this or that, just talk to me. I love talking to people. So let's go back to hypothesis. So hypothesis, before you know like what hypothesis is, I think you should know what is a probability-based testing. So probability-based testing is I would try to explain it by drawing some example here. So one is the testing by property. So that's the probability-based testing. Another is testing by example, which is what we call like when we do our normal way of testing. Well, I don't know, like normal is a very tricky word, right? But anyway, it's like how you usually, when we learn coding, that's how we do testing. So that's the test by example there. So first of all, test by property is that I would think that the given is obvious. So later when you see the example, when we test by the property, so as what the name suggests, we give the property about the test. So what do I mean by that? So for example, I have a function that I do some calculation, right? So I have an input x. X is a bad name anyway, x. So what is x? So if you test by example, you have to think of, okay, so x is a number, right? So I'm doing some calculation here, but do I allow a floating point number, or do I just allow integer? Do I allow any, let's say it's an integer, do I allow the negative integer, do I allow 0, and all these things. So I have to think about all these examples that fit the bill. But if we test by property, is we just given like what that x should be, right? So for example, x is a positive number, we can just say x is a positive number. That's what we provide for the test. So instead of putting all the examples like, okay, it's a positive number, so I test 1, 2, 3, but not testing 0 because it should never be 0 and things like that. I just say that is a positive number. So the next thing is that because of how it works, just by the example I gave you, you know that testing by property, half of the work is done if you are already doing the typing, right? So nowadays, people write Python code, and since I forgot when is that. So typing was introduced like by stage, and then I think now it got fully introduced maybe in 3.9. I'm not sure if I'm wrong. Please forgive me, but it was introduced like in the modern kind of time that when people write Python code, now we type a variable. So instead of like Python is famous for duck typing, now people are more strict about, okay, maybe we should be less messy and think ahead of what the type of our variables are and label them. So if you already done that, if you follow that kind of philosophy, then half of the work is done, because testing by property, that's all the tests need to know, what that variable should be. But testing by example, then you have to take extra step, right? You look at, okay, what's the typing? So it's an integer, that you kind of find the example that you should test there. Also, you have to come up with good example. For example, like maybe testing 1, 2, and 3 is a bit silly, because if 1 pass and 2 pass, then 3 probably will pass, right? So you may not want to test that. Instead, maybe you want to test something very big to see if it blows up or things like that. So yeah, that's what I just said here. Edge case, if we have a good strategy from hypothesis, then the edge case will be automatically found, because we cover the ground. So by having a good strategy, or the tricky bits is already given by the by hypothesis, or the strategy that you're using. But testing by example, every time you have to think about edge case, and so it's not as systematic as hypothesis. So let's talk about hypothesis then. Like now we know how we have test by property. So we know that the idea is that we only need to provide the type of the variable instead of providing example of the variable to be used in testing. So how does hypothesis do it? So there's two part. Mainly, I just break it down into a very, very simple kind of construct. The first part is a decorator. So we need a decorator to kind of provide entry point to the test. So when we write the test, right, you just have a test function, and then it got executed by PyTest or your testing suite. You can use unit test if you want, but I use PyTest as an example here because PyTest is my go-to. So you need to have a decorator to modify the test, so the test become a test that is work with hypothesis. And the next thing you have to provide is the strategy. Again, like, how do I know if this variable, for example, is a positive integer, what cases to test? So we have to write down the strategy. If whenever I see a positive integer, that's what I'm going to test. I got to test a few of the small numbers and a few of the big numbers. If it's like, for example, a non-negative integer, then we will include 0. So we definitely need to test 0 because it's a special case. So that's the strategy, right? What to test and what not to test, because they are not needed. Let's have a look at how hypotheses work in action. So this is an example that is actually in the documentation of hypothesis. So this is very, very simple, right? There's like two functions doing two things. You don't have to look at the detail here. But what it does is that for one, it do the encoding of some string. And the other one is the reverse, is do the decoding of some string, right? So you don't have to look at it. Like I said, it's just an example of how, like, there's two functions written that's doing coding and decoding. So how do we write a test for testing this? So this is how you write a test for testing this. This is a hyper simplified version. Of course, you may want to test more than just this, but this is an example. So first of all, we need the decorator. So the decorator is called given. So in hypothesis, there are multiple decorator you can use, but most of the time you'll be using given. Given is the decorator that you can actually provide a strategy for your variable. For example, this one, because remember we encode and decode some string, right? So we will use the text strategy here from the hypothesis strategies. And here you can see that when we apply that, that's like the decorator and then given, and we said that we use the text strategy because we have the variable s here down there. The variable s will be a text, and then it will do this. I call it round trip. You will see this again and again in this talk. So what it does is that because this pair of function is doing, one is doing encoding, the other is decoding. So if you encode something and decode something, it should go back to what it was, right? So this is basically testing that. So s should be a text. Okay, so this is very, very simple. Let's see if we can see how it works. So, I can't see what is going on here. Okay, terminal. That's what I want to. Oh, okay. Let's do it this way. Okay, let's have a terminal. Can you see the terminal? Actually, you can't see the terminal. Oops. Don't know why it happened like that. 1 second. So let me try again. I thought I was sharing the whole screen, but I think I made a mistake. Just 1 second. I'll fix it very, very quickly. Okay, now we should go back to here. Yes. And there's a pop-up window in my way anyway. Okay, so now you see my you still can't see my window. That's very, very annoying. Why is like this? Okay, so unfortunately the demo does not work. It doesn't show the whole screen that I'm seeing, so I can't show you the demo, but ideally I would like to show you how it works, but it doesn't. But anyway, you can try it at home if you have downloaded the slides, and you can just like copy this text and try it at home. Then if you run it, it will be my computer is doing funny things now. So you will see that actually you'll find an edge case if you run this code, right? Like if you get the code from this previous slides, and then you get the code from this slides, and then you run it, and then you'll find an edge case actually. So this is how like hypotheses work. Instead of thinking about what to test, and then you will find an edge case by just providing the right strategy. So hypothesis for scientific work. So why I'm kind of talking about hypothesis here in the PyData conference, because hypothesis work with NumPy, and actually they are so a lot of people think that okay, it's a testing library, but then it actually works. It designed for some of the scientific calculation, especially when you use a lot of numeric calculation and use NumPy naturally, and you can install that scientific stack that we call with this. If you have seen this before, this means that if you just install hypothesis, then it's a lightweight version of hypothesis, just consists of the core of what it is. But if you want some extra thing, for example, you want the extra scientific stack, then you have to put the extra bit with the square bracket here of NumPy. That's how you install the extra bits that works with hypothesis. And then you can import those tools that works with NumPy here by hypothesis.extra.numpy. And then, so it will provide strategy to test for the scalar and the D-type. So again, strategy is the number one important thing in hypothesis. Without a robust strategy, it won't be very, very helpful. So since now, hypothesis provide strategy for NumPy, so you may as well get advantage of it. They also pandas support as well. If you install that extra bit for NumPy, actually include the support for pandas as well. So it's the same. You install it, and then all the extras are located here. So, for the panda objects, right? So pandas, like the framing thing that you would use would be data frame, of course, sometimes series and index. So they are like you can have strategy for those. So, so it's quite cool. Again, like all the details can find on the documentation, so please check out the website there. And some people don't know, that's why I mentioned it here. So, what if I'm very, very lazy? So again, is another thing that some people may already use hypothesis, but they never try this out and don't know, is to not writing a test and let hypothesis write it for you. So, how does it work? So you see the little like the kind of like a small, the small print here. All the details are in the small print. I hope you're still using typing because for these to work, typing really does help. If you're not using typing, then it can help, but very limited help can be given. So we have a ghostwriter. So kind of is for me it's very interesting to name it this way because like imagine that there's like it's kind of like surreal that there's like someone like there's a ghost holding a pen and write all the tests for you. So it's kind of like that. So it's written for you automatically. So what it does is it will use typing as a hint. So that's why I said I hope you're still doing typing for your code because that is how the ghostwriter get the information about what those variables should be, and then that's got applied to writing your tests for you. And so you will pick the strategy depending on the type of your variable. And then it's a CLI tool actually. So again, like I wish I could show you the terminal and like show you that, but unfortunately, for I don't know why the StreamYard doesn't like me sharing the whole screen for some reason. I won't try it again. So unfortunately, you have to try it at home. But the command is super simple. I will show you later. And also the code will be black. So if, for example, you don't want people to know that you have been cheating, right? You have been like the code is not written by you. What you can do is to use black to help you to keep a consistent format of your code. So if you have been a fan of black, you have been using black, so your code will be more or less following this kind of black format, right? So it's an auto formatter for those of you who don't know what black the package is. So for the ghostwriter from Hypothesis, it will also clean up the code with black for you. So it will be consistent, with your style of writing, which is already formatted by black. So nobody knows that you cheat. That's amazing. So so this is how you can type in the command line. Again, I can't show you, so try it at home if you wish. Of course, you have to install Hypothesis, but then you just type in your terminal Hypothesis, right? And then this is the package name. So here we use an example gzip. Gzip is came with the standard library. So if you have a C Python or any kind of common Python installation that consists of gzip, then you would see the whole package, the whole module has been scanned, and then the test has been written for it. So it's really, really cool. I wish I could show you, but try it yourself. Trust me, it's fun. So there are actually multiple ghostwriters. So if you try that out yourself, you see that actually ghostwriter is quite smart. It used various strategy to help write the test. So there's like these are the kind of the way that the ghostwriter write the test. First is fuss. Fuss is just to try to run that function, right, to make sure that it works. So the first thing about unit testing is that thing works, right? So we're using fuss. But if you're expecting some kind of errors, then you can also include that here, because sometimes your code may throw some exception and stuff. You can also include that there. So it knows that it's expecting some error. So this is first one of the things that the ghostwriter will do. The other thing in that it's super hard to pronounce this word. But anyway, what it means is that for some functions, right? If you apply it once, if it's worked properly, it's done. So the job is done. If you apply it again, it won't change a thing. Sorting is a very good example. If you sort the list, if it got sorted properly, if it's not random, right? It's already in the order that you wish. So if you do the same operation again, then it won't change a thing. So this is what the ghostwriter is doing. So it's very useful for that type of function. If you have written any of those, that applying it once should already get the job done, and it should not be changed after. I think this is the fun thing. This is the thing I said happens all the time. It's the round trip, like our previous example, the encoding and decoding one. So when you apply, so they come in a pair. So if you apply the first one and then apply the second one, it should go back to where it started. So we have a lot of those actually in Python, not just Python, but in programming in general, because there are lots of things that come in a pair. That's beautiful. For example, we have the JSON library. It's in the standard library. If you have this CPython installed or any common distribution of Python installed, then you should already have it. There are lots of pairs, for example, JSON DOMs and JSON loads. Of course, they have JSON DOM and JSON load as well without the S. But they come in a pair. If you apply the first one, it doesn't matter which order actually. But I think it depends. So okay, yeah. Again, of course, like if you apply JSON loads first, then you have to have a JSON string. But if you apply JSON DOMs, then it would be a dictionary. So, but anyway, you apply the two. Consecutively, should go back to where it was. So this is the round trip, and this is one of the things that the ghostwriter would do. The ghostwriter is super smart. For example, if you apply it to our previous example, because we have hinted it by the name. One is called encode, the other is called decode. So hypothesis, we know that they are actually a pair. So what if you have multiple ones, right? If you put them in different classes, actually, hypothesis will also try to match the pair within the same class. So it's actually quite smart. Believe me, I've worked on this a little bit. I contribute a little bit to this part of hypothesis, and I'm so proud of it. So please check it out. And equivalent is also quite useful sometimes. If you have a function that you know that it works more or less the same as another function that you trust is correct, then you can use this. So this sometimes this I think this is like less frequent that you come into it. For example, I write my own power x to the power of y kind of function, and then I want to check it against the one in the math module, because the one in the math module probably is correct, right? So yeah, like things like that you can check. It's like checking another function against one that you believe is correct. So it's kind of like that. There's others that's like, again, less used. For example, binary operation. If you have written some custom binary operators that you can use this to check. And also we have things again for NumPy. So we have ufunc, because when you have the NumPy ufunc, when if you apply the ghostwriter and see some kind of NumPy stuff that it can that can be applied, and ghostwriter will do that for you. So that's very cool. So yeah, so I wish I could show you again. I can't do this, so it's coming to an end. Don't worry. Yeah, you can try it at home. So like I said, you have the link of the slides, right? So you can try it yourself. But before I end this talk, I want to kind of give you a feel, kind of a warning, or a grain of salt, because I am not like promoting you like to say, oh, you must use hypothesis or things like that, because like any other things, like it really depends on like what you're doing and what you want to achieve. So a few things to consider when you are trying hypothesis or try to apply hypothesis to your project is that tests can run much slower. If you have a big library, for example, why people will ask like, oh, why scikit-learn is not using hypothesis to test everything yet? Because we have all the tools that support numerical calculation, and they should use it. I've talked to the maintainer, and they said that, oh, actually it could be quite slow sometimes, because they have scikit-learn is a massive library, it provide a lot of tools for people to use. So having hypothesis to generate all the strategy for it can expand the testing into a massive kind of testing. That's why it will be much slower, and it may not be something that is desirable for the team. And tests can be harder to understand instead of having straightforward examples. Sometimes if you want to know what has been tested or what hasn't been tested, you have to really like trace back and see what hypothesis is doing. So it's not as straightforward as just writing some examples. Another thing, especially when you're using a ghostwriter, if you haven't typed your code, if hypothesis doesn't know what type of those variables are, it actually doesn't save you a lot of time, because at the end you have to go back to the code that hypothesis generated and then fix all these like type and the right strategy to use. So Yeah, so if you're super lazy, nobody can help you. I can't help you. Hypothesis can't help you. So sometimes, we like, we're engineers, we like being lazy, but don't be too lazy. Yeah. Okay. So that's the end of my talk. And thank you so much for listening. I'll go back to the first slide if nothing's happened. You can take a last chance to take a picture of it. Okay. I'll quickly go back. Or is there any questions? I don't know what's going on here. So
yeah, there's a couple questions. I don't know if you've addressed them yet. I don't know if you see it. One about the fuzz testing. You see this?
I can't see the question. If you can read it out, that would be helpful.
How about that?
Okay. Now I can see it. Yes. Is hypothesis based on fuzz testing, or does it pick from a set of? So yeah, it depends on strategy. Again, the strategy is the key. So for those simple one, it has been tested many times, so they're more or less like very robust. But if you have something very specific, you can write your own strategy. So it depends on the strategy, I would say.
What about this one?
So if I understand correctly, hypothesis generated that was a random factor that. Yeah. So for the strategy, I think for example. For the string, right? The text that I show you the example, so it will pick the for some of them is obviously you have to test like the empty string that would be the edge case, like, and also maybe a string with one character and then two character, but it won't test like 3 character 4 character because if 1 or 2 character passed, then we just assume the rest will be fine. So yeah, so that it won't be random. I think it will be some certain strategy that you know which are the edge case and it must be tested. But you can also provide the case that it must be tested. There are more like advanced usage of it, so I'm just covering the basic right now. So yeah.